Okay, for these final two problems, I took the liberty of getting the drawings already in here from the textbook just to save a little time. So the problem says that a guy wire runs from the ground to a cell tower. The wire is attached to the cell tower 150 feet above the ground. The angle formed between the wire and the ground is 43 degrees. How long is the guy wire? So again, the guy wire is this wire right here that's attached to our tower. And our tower isn't very special, but there it is. So, how can we figure that out based off of this information? Well, again, you just have to look at what side you have in relation to the angle that's given to you. So because we have our 43 degrees here, we do have our opposite side, and so we are trying to find the guy wire, which is the hypotenuse in this case, so let's call it R. And so now we should use sine, because we have opposite and we're looking for hypotenuse. So if we said the sine of 43 degrees is equal to 150 over R. Again, R is on the bottom, so we know we're going to divide the two. Eventually you develop little tricks to kind of save some steps. But until you do, like I said, use a proportion, cross multiply, and divide as necessary. So in this case, if we say 150 divided by 43 sine equals 219.94. So 219.94 and so on. And if we round that to one decimal place, well, we can see it does round it up to 220. So let's go with it. So 220, and don't forget your units, 220 feet. All right, how far is the base of the tower, is the guide wire anchored to the ground? So you can kind of see we want this distance down here. Let's call it X. So same thing, don't use the side that you found, use the information that's given to you, just to be safe. So we have our opposite and our adjacent is what we're trying to find. So tangent. So tangent of 43 should be 150 over X. So X should be 150 over the tangent of 43 degrees. So let's see what we get in this one. Divided by 43 tangent equals 160.855. And we'll round it to one place. Now, some of you would say, well, can't we just round it to 161? It's pretty close, right? Yes, it is, but again, I like to err on the side of a little bit of accuracy. So too much rounding is just too much rounding in my book. So that wraps up that problem pretty quick once you make sure you understand what you have and then just using the right trig ratio. So, all right, let's try the last one. Again, I took the liberty of drawing it in. So we have a steel plate has the form of 1/4 of a circle with a radius of 60 centimeters. So you can see that's what we got here. And 60 centimeters goes all the way up to the outside edge here. 2 centimeter holes are drilled in the plate, positioned as shown in the figure. Find the coordinates of the center of each hole. So this one's a little bit trickier. So you can see we have the 2 holes here. So we want to know where the center of those holes is going to be located based on this. So you can see that they have this 56 that's kind of going around here. So we got to try to see how we can figure this out. Now we're going to need coordinates. So we need an X and a Y coordinate for each of these holes. Well, the big thing is if we're looking for X and Y, we have to know how far to the left or to the right that we have to go and how far up we have to go. So if we dropped a vertical line from that first hole, that value of x is going to be dictated by this side here, x. And same type of idea for the vertical, that's going to give us our height, so that we can call y. All right, well, so we have two sides that we don't know, but what about the third side? Do we know what that one is? Sure we do. If we swing this 56 up to this point, that tells us the hypotenuse must be 56. So we do have enough information to get those coordinates, but let's just do them one at a time. So for this one, let's call it x1, y1. I think that's the way they did in the textbook. We'll call this one x2, y2. So we have two different points, two different ordered pairs. So this would be x1, this would be y1. All right, so let's start with x1. So we have our angle of 30 degrees. x1 would be the adjacent, and we said we do know the hypotenuse, which is 56. So that must mean cosine. So cosine of 30 degrees should be our x1 over 56. So x1 should be 56 times the cosine of 30 degrees. So let's see what we get. So 48.49, now we can round that to 5. So 48.497 dot 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 48.5. So we're not going to worry about units or anything at this point. So we're just going to start with that. All right, let's get our y. So now we have the opposite and the hypotenuse. So sine. So y1 over 56 and so I think this one might be 28, but let's just verify. Yeah. So that should be the coordinates of our first point. So x1, y1 should be equal to 48.5, comma, 28. All right, let's do the next one. So we're going to have to draw a new triangle. Again, we want to drop a vertical line from that point down and get our new values. So let's do the same thing. Our horizontal distance here now should be x2, and our vertical distance should be the y2. But what about our angle? Well, now we got to be careful because now we got the two 30 degrees, so we now have 60 degrees, but we still have that same hypotenuse of 56. So if we want to find x, we're going to have to use cosine again of our 60 degrees equals x2 over 56. So let's see what we get. I'm thinking we might get something suspicious because we want to multiply again. So 56 times the cosine of 60 degrees. So 56 times 60 cosine equals 28. So riddle me what you think the next one's going to be. Because we're still going to use 60, but we're going to have to use sine because we want that opposite. So y2 over 56. And I think you can guess. So 48.497 or 48.5. So x2, y2 should be just the opposite. And hopefully that makes sense. Just of the nature of the symmetry of this, you can kind of see it's going to have to be that. If you know the coordinates of this one, you know the coordinates of this one as well. So there's our solution. And that wraps up 4.3. So stay tuned for the next video where we jump into 4.4. Take care.